For over a century, oil production was largely confined to land, with towering derricks dotting landscapes across the globe. As our thirst for energy grew, exploration ventures pushed further, seeking new frontiers. The discovery of vast oil reserves beneath the ocean floor marked a pivotal moment, ushering in the era of offshore oil production. This move from land to sea brought about new challenges and necessitated the development of innovative technologies and strategies. The transition from onshore to offshore production wasn't merely a change in location, it represented a significant technological leap, demanding robust engineering solutions to withstand the unforgiving conditions of the open sea. Moreover, it brought to the forefront critical considerations about environmental responsibility and the sustainable extraction of this valuable resource. When contrasting onshore and offshore oil production, several key differences emerge, each with its own set of complexities and implications. Firstly, location plays a critical role. Onshore drilling occurs on land, making it relatively straightforward to transport equipment and personnel. This accessibility translates to faster setup times and reduced operational costs. Conversely, offshore drilling takes place in the ocean, often miles from the nearest coastline. This remote setting requires specialized vessels and helicopters for transportation, making logistics more complicated and costly. Secondly, the technology used in each environment differs significantly. Onshore drilling rigs are typically less complex and easier to construct. In contrast, offshore platforms must be engineered to withstand harsh marine conditions, including strong currents, high waves, and corrosive saltwater. These platforms are often marvels of engineering, incorporating advanced technologies for stability and safety. Thirdly, the costs associated with each type of production vary greatly. Onshore drilling is generally less expensive due to easier access and simpler technology. Offshore drilling, however, involves higher initial investment and ongoing operational expenses. The construction of offshore platforms, transportation of materials, and maintenance of equipment all contribute to these elevated costs. Finally, the environmental impact of each method must be considered. Onshore drilling can lead to land degradation, habitat disruption, and potential contamination of soil and groundwater. Offshore drilling, while avoiding these terrestrial issues, poses risks to marine ecosystems. Oil spills at sea can have devastating and far-reaching effects on marine life and coastal communities. In summary, the differences between onshore and offshore oil production extend beyond mere location. They encompass varied technological requirements, cost structures, and environmental considerations, each demanding careful planning and execution. The most apparent distinction between onshore and offshore oil production lies in their locations. Onshore drilling, as the name suggests, takes place on land, while offshore drilling ventures into the depths of oceans and seas. This difference in location directly impacts accessibility. Onshore sites are easily accessible, facilitating transportation of equipment and personnel. This ease of access translates to quicker setup times and lower operational costs. Offshore platforms, on the other hand, present logistical hurdles. Located miles from the coast, these platforms require specialized vessels and helicopters for transportation. The remote nature of offshore operations necessitates self-sufficiency, with platforms housing living quarters, power generation, and other essential facilities. This isolation also poses challenges for emergency response and evacuation procedures, demanding rigorous safety protocols. The contrasting environments of land and sea have driven the development of distinct technologies for onshore and offshore oil production. Onshore drilling commonly utilizes vertical wells, drilled directly down to the oil reservoir. The equipment used is often mobile, moved from site to site as needed. Onshore operations can leverage existing infrastructure such as roads and power grids, further simplifying logistics. Offshore drilling presents a unique set of challenges demanding specialized equipment and techniques. The ocean's depth, currents, and unpredictable weather conditions necessitate robust structures. Offshore platforms are marvels of engineering designed to withstand harsh marine environments. Drilling techniques vary, with directional drilling allowing multiple wells from a single platform, maximizing resource extraction. The technology employed offshore is continuously evolving, with advancements in subsea systems, remotely operated vehicles, and deep-water drilling techniques. Section 4. Economic considerations, costs, risks, and rewards. The cost of oil production is significantly influenced by the location and technology used. Onshore production generally entails lower costs due to easier access, readily available infrastructure, and simpler technologies. However, onshore fields are often smaller and mature, yielding lower production rates compared to their offshore counterparts. Offshore production, while capital-intensive, often taps into larger, more prolific reservoirs. The high upfront investment in platforms, drilling technologies, and logistics can be offset by the potential for higher production rates and longer life cycles of offshore fields. However, offshore projects carry inherent risks. The remoteness and challenging conditions increase the probability of delays, technical difficulties, and environmental incidents, all of which can escalate costs. Section 5. Environmental impacts. Navigating a sensitive balance. Both onshore and offshore oil production have environmental footprints, raising concerns about their impact on ecosystems. Onshore operations can disrupt local habitats, fragment wildlife corridors, and potentially contaminate land and water resources through spills or improper waste disposal. The visual impact of onshore infrastructure, including drilling rigs and pipelines, is also a consideration. Offshore production presents its own set of environmental challenges. While the footprint on land is minimal, offshore activities can disrupt marine life through noise pollution, accidental oil spills, and the discharge of drilling fluids. The transportation of oil from offshore platforms also carries the risk of spills, potentially impacting coastal ecosystems and communities. The debate over the environmental impacts of oil production, both onshore and offshore, underscores the need for stringent regulations, technological advancements to minimize risks, and a commitment to sustainable practices.